In this podcast episode, Dr. Andrew Huberman interviews Dr. David Eagleman, a renowned neuroscientist, author, and science educator. The conversation explores a range of fascinating topics centered on brain science that profoundly impact everyday life. They discuss neuroplasticity and strategies to enhance learning and unlearning, the formation and distortions of memory under stress, mechanisms of time perception, and how it relates to traumatic events, neuroscience behind cultural and political polarization, sensory substitution technologies, dreaming, and the complex interplay between science and societal constructs such as law and identity. Throughout the discussion, practical insights and novel scientific discoveries provide listeners with tools to better understand and optimize their own minds. David Eagleman explains neuroplasticity as nature's ingenious strategy, allowing humans to be born with a half-baked brain that the environment wires up based on experience. Unlike other species with fixed behaviors, humans possess an extensively flexible cortex, about 4 times larger than that of other animals, which enables us to absorb language, and all manner of information during development. This adaptability explains why genetically identical humans born in different eras or societies would be fundamentally different people. The cortex's uniform 6-layer structure executes similar algorithms regardless of sensory modality, and its function depends on the inputs it receives, visual or auditory, for example. Experimental rewiring studies show the brain's remarkable flexibility, with auditory cortical areas able to process visual information in cases of congenital blindness. Eagleman emphasizes that the brain is a network of dynamic little creatures, neurons, that continuously reconfigure their connections to optimize functioning based on experience. Plasticity underlies skill acquisition by transforming effortful software into automated hardware. The prefrontal cortex, uniquely developed in humans, allows simulation of futures and complex decision-making by interposing computational processing between sensory inputs and motor outputs. He stresses that to maintain plasticity, one must constantly seek novel, challenging experiences that prevent the brain's model of the world from becoming static. The discussion turns to early specialization in activities such as sports and creative pursuits, with reference to recent scientific findings suggesting that a more diversified approach to physical and cognitive activities in childhood tends to yield better peak success later. While examples like Tiger Woods and the Williams sisters demonstrate the power of focused training, Eagleman points out that intense repetition builds skill deeply into brain circuitry, resulting in efficient neural processing seen in experts. However, early diversification exposes children to a breadth of challenges, ensuring a wider base for future growth. Genetic predispositions influence talent and abilities, but broad exposure is valuable for fostering critical thinking, creativity, and adaptability. For instance, bilingual children may have a smaller vocabulary in each language compared to monolingual peers due to practice split, yet language learning and musical training enrich cognitive flexibility and reward systems crucial for plasticity. The ability to remix foundational knowledge across domains is what constitutes creativity, and educational systems should encourage compressing foundational material to allocate time for creative experimentation. Eagleman highlights that continuing to push the brain with novel, achievable challenges maintains plasticity throughout life. Studies of members of religious orders who remained socially engaged into their 90s illustrate how lifelong activity preserves brain function despite pathological changes. He warns against over-reliance on passive activities like puzzle solving once proficiency is achieved, urging continual exploration of unfamiliar domains. Regarding neurochemical modulation, multiple neuromodulators, acetylcholine, dopamine, serotonin, norepinephrine, have overlapping roles in enabling plasticity. He notes acetylcholine as a primary driver when the brain encounters predictions errors requiring model updates. However, attempts to artificially boost neuromodulation must be cautious, as exemplified by Parkinson's patients on dopamine therapies developing compulsive gambling due to altered risk assessment. The goal is directed plasticity to rewire useful changes without destabilizing identity or functional systems. A significant concept introduced is the Ulysses contract, named after the mythical figure who bound himself to resist the siren's call. as a strategy to manage future impulses that might undermine long-term goals. People employ social accountability, monetary stakes, physical constraints, and environmental modifications to protect their future actions from momentary lapses. For example, locking phones away during work or making gym appointments with friends serves as mechanisms to bind one's future self to productive behaviors. People often overestimate their ability to control impulsivity in future states, and successful self-regulation depends on designing contracts that account for future weaknesses. While avoiding detrimental behaviors by constraints is relatively more effective, fostering positive behaviors requires similar scaffolding. Removing friction, embedding habits, and leveraging social pressure can help bridge the gap between present intentions and future action. The brain's inner dialogues between competing impulses necessitate balancing reflection and decisive action. The episode explores the spectrum of mental imagery abilities, ranging from aphantasia, lack of mental images, to hyperphantasia, vivid movie-like imagery, and their implications for creativity and perception. Surprisingly, many top animators and artists possess aphantasia, compensating with detailed analysis and practice rather than spontaneous mental vision. This challenges assumptions about the nature of creativity and underscores how diverse internal representations support skilled behavior. The ability to consciously visualize interacts with how we experience dreams and memories, though no clear correlation exists between imagery vividness and dream quality. Different people rely on varying cognitive repertoires, emphasizing the importance of adapting learning and creative strategies to individual neurodiversity. David Eagleman's research on the perception of time during high-stress, life-threatening events reveals that subjective time dilation is not due to a speeding up of perceptual frame rate, but to the denser encoding of memories through amygdala-driven pathways. In a unique experiment involving humans dropped from a 150-foot tower, subjects' perceptual processing speed did not increase under freefall stress, yet retrospective reports indicated elongated duration because of richer memory compilation. This memory-based time distortion explains why traumatic or novel events seem to slow down in hindsight, whereas routine experiences, especially with age, feel like they pass quickly due to sparse memory encoding. Such insights inform how stress and attentional focus influence memory reliability and subjective experience of time, with applications in therapy and understanding trauma. Eagleman discusses technologies that rechannel sensory information through alternative modalities, a testament to the brain's plug-and-play plasticity. For example, the BrainPort device converts visual input into patterns of electrical stimulation on the tongue to provide blind individuals with spatial awareness through tactile sensation. Similarly, vibrotactile wristbands can transform sound into patterns felt on the skin. The brain can interpret these signals as hearing or seeing, demonstrating deep adaptability. Moreover, sensory augmentation devices like compass belts provide novel perceptual inputs, e.g., directional cues, that users can learn to integrate, hinting at the brain's capacity for entirely new senses. Dreaming, particularly during REM sleep, is interpreted here as the brain's mechanism to preserve primary visual cortex territory from takeover by other sensory modalities during nightly darkness. Because the visual system experiences prolonged inactivity at night, neural circuits generate internally driven activity patterns, dreams, to maintain cortical integrity and prevent cross-modal takeover. This evolutionary hypothesis is supported by comparative data showing more REM sleep in species with extended postnatal plasticity, such as humans. Dreams originate from deep brain to visual cortex circuits activating during REM, and people who are congenitally blind experience dreams composed of tactile and auditory sensations instead of visual imagery. The discussion addresses challenges posed by the malleability of human memory, especially in legal contexts. Witness memories, even for traumatic events mediated by amygdala-enhanced encoding, are subject to distortion, decay, and contamination through social influence. Policing procedures have evolved to reduce suggestibility and memory contamination, such as isolating witnesses and carefully managing lineups. Children are especially susceptible to false memories due to greater suggestibility, complicating testimony reliability. Conversely, modern digital life, with ubiquitous photo and video documentation, may anchor memory more firmly, but can also distract from direct experience. The podcast notes the legal system's difficulty balancing reliance on eyewitness testimony with understanding its fallibility. Eagleman's lab uses neuroimaging to demonstrate how empathy is modulated by group identity. Activity in the brain's pain matrix is intensified when observing in-group members suffering and diminished for out-group members, underscoring an implicit bias wired into social cognition. This effect extends to arbitrary group assignments and tribal affiliations, illuminating basic neurobiological underpinnings of political and cultural polarization. Historical atrocities are cited as examples of extreme polarization fueled by dehumanizing propaganda, which suppresses neural empathy responses by framing outgroups as subhuman. The solution involves complexifying social relationships across group boundaries and employing educational tools to reveal cognitive biases and the limits of one's internal model of reality. Eagleman proposes social media algorithms that highlight shared interests and human connections before surfacing contentious differences to foster dialogue and reduce polarization. The conversation touches on addiction as a form of maladaptive plasticity in which repeated exposure to a substance or behavior causes receptor upregulation and heightened expectation of continued use, resulting in withdrawal symptoms upon cessation. This model extends to non-substance behaviors such as gambling and social media use, where dopamine-driven reward systems create compulsive patterns despite negative outcomes. While social media provides unprecedented access to information and learning, it also presents risks of reinforcement loops, leading to narrowed pleasures, reduced attention spans, and potential emotional exhaustion. Balancing engagement and mindful use is critical to mitigating these effects. Drawing on the work of science writer Ed Yong, the discussion highlights that the relative importance of a sensory modality for an organism depends on reliance rather than raw acuity. Many animals possess extraordinary senses such as echolocation, magnetoreception, or infrared detection, which humans can partially acquire through training or technological substitution. The brain's general-purpose computation and flexible wiring make it uniquely capable of integrating novel sensory inputs, forming a foundational principle behind sensory substitution and augmentation technologies. Eagleman expresses optimism about the democratization of education through AI and the Internet, enabling personalized, curiosity-driven learning. AI can serve as a patient debating partner to develop critical thinking. Technology enables learners to access specialized knowledge instantly, a stark contrast with previous generations who faced barriers in obtaining information. The podcast underscores that engagement rooted in curiosity greatly enhances plasticity and long-term retention, pointing to a pedagogical shift focused on individualized, active learning. Dreams, mainly occurring during REM sleep, involve vivid imagery generated internally by stimulation of visual cortex areas, even when the eyes are closed and disconnected from external input. Dream stories often embed emotional and narrative structure, characteristic of the brain's storytelling tendencies. People who lack visual imagery, such as those with aphantasia or congenital blindness, still experience dreams but primarily in other sensory modalities, reflecting the brain's accommodation of available input regions and wiring. The dialogue touches on language and terminology, emphasizing the importance of respectful labels for people and animals to preserve neural empathy and societal cohesion. Dehumanizing language correlates with reduced empathic brain responses and increased risk of violence and conflict. Eagleman warns that understanding the biological roots of identity, model limitation, and bias is vital for fostering tolerance and productive societal discourse. He advocates educational reforms and thoughtful social media design to counteract divisive dynamics by encouraging recognition of shared humanity and diverse perspectives. In addition to his research and teaching roles, Eagleman hosts the Inner Cosmos podcast, delves into writing new books, including topics like the Ulysses contract related to behavioral self-binding, and a forthcoming work titled Empire of the Invisible, addressing cognitive modeling of reality. He is also involved in innovative projects combining neuroscience with entertainment, such as a documentary exploring whether AI can perform comedy in collaboration with comedian Craig Ferguson. Alongside intellectual pursuits, Eagleman enjoys practical activities such as home repairs and raising a family, embodying a balance of scientific curiosity and grounded living.